So gaining different perspectives really help us consider the AI story holistically. After hearing from the investment side, let's see what educators too are seeing from the academic point of view. As Albert mentioned earlier, Kneron is greatly invested in supplying educators with the right tools to make AI development accessible at all levels and classrooms around the world. We see it as an evergreen driver for the future of AI. So first, we'll listen to Professor Li of Princeton, Professor Tsu-Chin Tsao of UCLA, and Professor Cong Sheng of the University of Virginia, who joined Max Smolaks from AI Business to discuss their thoughts on teaching AI development today.
Hello, and welcome to this panel on AI and education organized by Edge AI software and hardware vendor Kneron. My name is Max Smolaks. I'm the editor at AI Business, the publication entirely dedicated to artificial intelligence in business. I will be moderating this session and asking a few questions. And our panel members today include Professor Li from Princeton, Professor Cong Sheng from University of Virginia, and Professor Tsu-Chin Tsao from UCLA. Thank you, gentlemen.
Thank you.
I'm a professor at Princeton University in computer science department. My research expertise are in the area of in several areas, in computer architecture, in distributed parallel systems, and also in building knowledge base. For example, I and my former colleague co-led the development of ImageNet, which helped propel the deep learning to become a dominating approach in machine learning. And currently I'm teaching courses, graduate courses in systems of machine learning at Princeton.
All right. Thank you. And Professor Cong Sheng?
Hi, yeah, this is Cong Sheng. I'm on the faculty at the University of Virginia, and I'm with the Electrical and Computer Engineering Department. My research and my expertise are largely on wireless edge intelligence, edge AI, but with application more on the wireless end. And more specifically, I'm working on problems such as how do we enable large-scale distributed machine learning over, for example, wireless networks, and how do machines collaborate with each other to perform learning for a central task, and how does wireless communication or wireless network affect the learning performance. And before coming to University of Virginia, I also had quite a few years of experience in industry, mostly in wireless communication companies such as Qualcomm. I got my PhD from UCLA quite a few years ago. Yeah, that's my background.
All right, thank you. And Professor Tsao?
Hello, thank you. I'm a professor at Mechanical and Aerospace Engineering Department at UCLA. My background, my area is research areas is in control systems, robotics, and something called mechatronics, which means integrating mechanical, electrical, electronics, and software as a system. And that's sort of the area of my research, and it's also the classes I teach that involve from theory of controls to all the way to student design project that realize this type of systems. And so far, AI has only been considered and sort of been explored in my research projects like robotic, surgical robotic robots research, and unmanned aerial vehicles. We haven't really adopted AI in our education, like courses, in required courses. Yes.
Okay, thank you. Yes, it's an interesting time to be in AI, absolutely. An interesting time to be sort of on the education side. What do you think about the supply of skills at the moment? So many organizations sort of like have highlighted that the demand for, like specific workers with specific skills useful for AI, data scientists, data engineers, like people who can design silicon, it seems to be increasing while the supply of the skills is not. Like if anything, universities sort of like are in a bit of a crisis right now because of the pandemic. So how do you think we solve this problem? Because there's clearly an interest among businesses, there's appetite to invest in AI-led projects. How do you think we're going to get enough people to build all the cool stuff that we want to build? And I guess we'll start with Professor Kylie for this one.
As you said, I think there's a very strong demand in the industry and in the society in general for machine learning or AI. I think that the education systems, my personal feeling, the education system is still experimenting how to teach courses. Typically, if you look at the history, when the new technology emerged, and educational system obviously have professors doing research in the front end, and together with that new direction. But to educate a large number of students, to equip them with the knowledge to respond to the demand, I think that's required several iterations. The iteration of developing a better textbook, involving a good set of projects and a good set of lab equipment. I think that requires some iteration. My view is we're still in the first iteration. So we're still learning about what's the best way to teach students. And most of the universities have close interaction with the companies. So we do get feedback from them, especially when the students going through the interview process. Also, we have shared collaborations. We have collaborations with various industry partners, and they will tell us what type of students they expect to have and what type of students they're interested in recruiting in the future. So we're constantly adjusting how we teach students right now.
Mm-hmm. Okay.
One example is that, for example, in computer architecture, I think more than 10 years ago, John Hennessy and Dave Patterson developed a very good textbook. And after that, I think a lot of universities or many departments adopt the same textbook and have a similar teaching style. But before that, I think there are many different textbooks, different universities teach differently. I think, so that I feel like that particular round of iteration was towards the end of the iterative development of teaching computer architecture, for example. But early on, there are many different ways of doing things. We are at the early stage of doing, figuring out how to teach AI and machine learning at this point.
Okay, thank you. Professor Cong Sheng, what do you think? Like, is it interesting to be like in a place where there's very little existing methodology? Where you have to invent methods to teach your students?
Yeah, I think actually I totally agree with what Professor Li just mentioned. I think we are at the very early phase of figuring out how to systematically and effectively teach AI and machine learning and data science in general to students. And this is mainly because this is obviously a field that is, developing really, really fast. It's not close to being mature yet, So I think just like every other field, the research always comes first. That pushes the boundary of the field. And then the education kind of slowly catches up after that. And also, generally, it takes time, I think, for educators, because many of the educators, like myself, actually are also researchers. So we kind of have to put both hats on. And the research hat is obviously very different from teaching, because you are thinking about new things. You're thinking about how to push the boundaries. But the education part is really how to expand this in a systematic way. That takes a lot of time and effort, and you can only do that after you yourself have a very kind of deep understanding of this field, of the what has happened and what is the fundamental of this field. And I don't think we're there yet. But the fact, I think, is also that we need significant amount of engineers, I think not just in the US, but across the world. And so there is a strong kind of urge to push the education to catch up with this demand. And another thing I wanted to add is obviously, I think at least one of the hopes in my mind for this to be possible is that we are not just relying on researchers or educators who are purely coming from computer science or machine learning or statistics background to teach this. And I myself actually come from a more engineering background, in wireless communications, some hardware, etc. And I went through the process of learning AI and machine learning myself. And I believe there are many professors who are coming from different fields, but they are all interested in AI now because first and foremost, AI is useful for many of the research projects that we are doing. But on the other hand, I think professors like myself and many others, we come from different backgrounds. So we kind of have maybe in a better position to combine AI with specific applications, because I don't think it makes sense to just teach pure AI or pure machine learning, because many of the applications nowadays, many of the companies who hire data scientists here, who hire machine learning engineers, they want them to use machine learning to still solve specific engineering problems. So it's important to have this domain knowledge combined with the AI, and that's I think where faculties who have both the background of the specific domain and the machine learning and AI I think would be very helpful. And these faculties, the number of them are significantly larger, I think, than the ones who just teach pure AI and machine learning.
Okay, thank you. And Professor Tsao, so you come from a hardware engineering background as well. So what do you think about just the amount of people who can do the job? Like in terms of like silicon design. Like how do we get more people into this profession?
Well, I totally agree with what Professor Li and Shen mentioned about it has to all start from faculties who do research in this field, and then somehow they abstract it, they consolidate the knowledge to become a set of well-presented knowledge that to educate students. And I think from sort of the more application side, which is in my part is mechanical and aerospace engineering, I think besides the sort of the background foundational knowledge that build up AI, I think the application side, I think like our students will be more like users of AI, and the application side will need things like data sets for different application than just like looking at this image and then say this is cat or dog type of thing that's typical for benchmarks in computer science field. What we need is scenarios and application that's really drive home for students in our field. For example, in mechanical and aerospace engineering, the student passion in these majors is something that moves, right? Any movement will be of interest to the students, like a movement of objects, fluids, heat, and so forth. And so, for example, autonomous driving would be something that's very inspiring for students. And so what I'm trying to say is that I think what we would need to see is, for example, people in this type of field like myself, and to have more access to data that's beyond what currently prominent data sets and examples and benchmarks that's beyond the current that get into more applications in each different majors, like our majors and so forth. And that would be the penetration for AI into educations in our field. And I can see the penetration probably will start from classes like control theory, which already have a lot of like linear regression estimation type of thing. And that could certainly extend to include more AI type of algorithms. And then for our student projects, that definitely realization of product that has some smartness that requires AI would be very logical. And so that's what I see is needed is data set examples and scenarios and the hardware, like Arduino type of hardware that's very easily accessible, cost effective, and for education purpose, for realizations. Thank you.
Yeah. And talking about exciting case studies. So last week, America's Advanced Defense Research Agency, DARPA, ran a competition where they pit a professional fighter pilot against an AI system, 8 different AI systems actually, and one of them just won 5-0 every single time. So yeah, I think when you read headlines like that, you think like, wow, okay, this is an interesting, and these are interesting engineering problems they're solving. And like, so what happens to the fighter plane when you don't have to worry about a soft and squishy being inside? Like what kind of maneuvers you can do. It's all very, very interesting. Okay, we talked a little bit about the need for AI skills and the supply of AI skills. What do you guys think are the main challenges for educators implementing AI? Like when you teach, so like some of these AI-related disciplines, what's the number one problem you're facing? And if we can start with Professor Shen.
Oh yeah, sure. I have actually been teaching, as I mentioned before, like communication courses and some probably a little bit more theoretical courses. But for every one of them, I have been trying to incorporate AI and machine learning into part of the curriculum. And this is not only because some of the, as I said before, the newest development in these respective fields incorporate AI as part of the tool, but also because students who are taking my classes in this way would benefit from the added expertise in knowing how AI can impact this particular field. I'll give you an example. I taught a course on wireless communications last semester. This course historically has been a very standard course, I think over at least the last decade or so. We always teach the course the same way. There is standard textbook, which out of maybe hundreds of textbooks, kind of really stands out, and a lot of universities are using this standard textbook, and we teach following the chapters and etc. But over the last couple of years, we have seen that because of the research frontier of this field is moving with this new toolbox of AI and machine learning, a lot of new results and kind of a new techniques have emerged. And for some graduate level courses, this would give us an opportunity to incorporate AI and machine learning into the curriculum. And the difficulty really, from my experience, I've seen 2 difficulties. The first one is obviously, this is a new tool for most of the students that come from the engineering background. For example, they are more familiar with, let's say, C and C++ programming. They are more familiar with hardware, programming, type of techniques. And then when it comes to a massive amount of data, training neural networks, optimizing over, for example, GPUs, things like that, they have not really had the fundamentals, to do that. That's, I think, issue number one. For some of them, I have to basically start from the very basics, like Python programming, explaining how, neural networks work. A lot of things we have to basically teach them, especially in a hands-on fashion. The second is I think for many of the engineering materials, we're not just running deep neural networks on a GPU and getting as Professor Tsao said ImageNet or typical classification results. We want to see machine learning and AI in my class. We want to see how that affects communication performances, and then you have to develop new materials. You have to develop new projects, new materials to show that by doing this, it is better than the way that we have taught this course in the last 10 years. So how to design that new material is a challenge because you not only want to show the cases where AI and machine learning give you better performance, but you also want to make sure that this is a deep result in the sense that the students understand that in this, for example, additional computation requirements, complexity, basically the whole picture. You have to teach them the whole picture. It's not just the research, again, just the research frontier. You have to teach them fundamentals. So these are the challenges I've seen so far in kind of, teaching AI related engineering courses.
Okay, thank you. Thank you, Professor Shen. And Professor Li, yes, so the main number one challenge when you go into a classroom and you start teaching something that relates to AI.
Well, I think the challenges I have is similar to Professor Shen's talked about. In my case, I'm teaching mostly graduate students. So I've been teaching system and machine learning graduate seminar for the last 3 years. And this course is about teaching students how to build systems for machine learning. For example, how to design hardware accelerators, or how do you design the system software that runs on different type of hardware, such that you can make a machine learning, running machine learning applications fast. This is one part of the course. The other is how to apply machine learning methods to designing systems. For example, is it possible you use machine learning to solve problems that it's very difficult to solve in the past when you design systems. For example, one of the probably common problems is to design a cache bridging between fast access to slow access. Like if you typically have a storage system, or on the internet you have a content distribution network, typically to deliver this content fast from the storage system user or from the network to user, you have a cache sitting somewhere near the user. What to keep in the cache, what's not to keep in the cache? This has been studied for 5 decades. And now machine learning comes along now. I think that has transformed how we design systems in research. And therefore, there are new ideas how to design cache in a new way that can do substantially better than just using heuristics. Then similar type of things will happen in designing compiler, designing network protocol, and so on and so forth. So this is how to apply machine learning to a variety of system design problems. Right? I think, for example, Google Brain has made a lot of progress in this area, and academic community also are making a lot of progress in this area. So this are the 2 themes we have in the graduate seminar. And now next year, we're planning to turn this into a graduate course, which will have the challenge of probably half of the courses we need to lecture the materials like the students must learn, as opposed to just reading the latest research paper and discussing them. Probably will spend half of the time doing those things. I mean, the reason I describe this transition process is that this is no other university has a definitive way of doing this. So each party is experimenting how to do this, right? We are one of those 2. I think one of the big challenge, 2 challenges I feel that's worth mentioning. One is to teach students how to define a machine learning problem. It's often the case that once the problem is well defined, and then you can figure out how to design loss function, you can design, you can pick network architecture if you do deep learning, and you'll be able to probably solve that problem, how to build up the gold standard, how to, the training data set with knowledge base, how would you form that, and then just the programming how to do machine learning, in some sense, is the easier part. How to define the machine learning problem, I think, is more challenging, and how to build knowledge base is equally challenging. So those are the one challenge. How do we teach students to do all those things? Not just here's the algorithm, how do you do this? The second part is actually related to hardware. How do you set up the lab such that students can actually run their projects or homeworks without feeling their hardware is the bottleneck? I think currently, typically when you do teaching, you don't really use the research equipment. For example, if you have a research cluster of GPUs, you don't really want 100 undergrads, even 50 graduate students in graduate course to use it. So now we may probably have to go to the cloud. Amazon AWS, Google Cloud, or Microsoft Azure, or some other emerging places like a cloud lab and so on. But where do you get the credits to pay the students, to pay for this execution time? The bill can go up very quickly. So typically universities do not have a specific budget for this, or that much budget for this. So that has been challenging to me. For example, students could run their training on their laptop as the sort of homework 101 and to figure out how to use machine learning to recognize the handwriting digit. And that's like a well-known machine learning 101 using deep learning approach. But when you start using ImageNet, even the mini ImageNet, a small subset ImageNet, and we're talking about training for days to do, one day. So the gap is gigantic, right? So where do you find the computing resources? How do you avoid students' frustration? I think that's one of the challenges here. So if you design a programming assignment or designing a project, you want the project to have a reasonable scale so the students feel like they're actually dealing with a reasonable size of data set, not just, a small data set with 10,000 objects. You want them to think about millions, right? But then do you have the resources to let them run things on millions of objects, data sets with a million objects? I think that's, this has been a challenging issue. Even a rich university like Princeton, this is still an issue.
It's interesting, yeah, because okay, you're a student, but you need this, just like machine worth 5 to 10 million just to test out your theories. I mean, the cost of entry is quite high into the field. All right, we'll probably come to our next and final question, and this one will probably start with Professor Tsao. The relationship between hardware makers, AI software companies, and AI educators. Do you think there's enough cooperation going on? And how can private companies, help the academia?
Yes, of course. First, I'd like to echo what Professor Shen and Li mentioned in the previous question about what's the challenge for education. And that probably leads to sort of how companies can collaborate with educators in these aspects. And so like what Professor Li said, problem formulation and setting up project labs is a main challenge, right? And actually, and I think that's crossed all, sort of engineering majors. And as our education moved toward from very specific topics, subject topics, to more complicated, or not necessarily complicated, but topic that require cross-disciplinary type of integrations. And that become more and more challenging. And so that probably, so probably the requirement would be more like a cross-majors type of collaboration among colleagues. Like, I'm gonna learn AI from my colleagues in computer science, and then we will set up some particular domain-specific applications for student education, and company can come in to help. And so since I haven't have this kind of experience, so what I'm saying is more like a wish list, right? So I'm saying that sort of repeating what I said before, that I think from our application point of view, mechanical and aerospace engineering, there's a lack of data sets for instructions that's relevant to our fields. For example, if the example could be like identifying manufacturing defects, then facial detection, that would be very helpful. There's a lack of benchmark and prototype type of AI examples for our education. I can see our education involve two types of problem. One is to solve inverse problem of a very complex mapping. For example, nonlinear fluid flows or heat transfers or structures, which may have well-developed forward model, for example, numerical algorithm or finite elements. But to find the inverse is very difficult, right? And that's where AI can come in, and that if we have those kind of example, that would be very useful for how to motivate students and to show how AI applied to computation. And I call it computational AI. And then go to like setting up project labs. That would be more like experiential AI. And I see this is, and so the previous computational AI, I already see a company can come in to help collect data sets or coordinate among educators, collect data sets and example problems, not many, but become prominent example for each different major fields, different majors. And then for the more application side, lack of low cost and easy to realize and integrate type of embedded controller that involve AI. Like I said, sort of like Arduino type of thing for robotic type of projects will be very helpful. But in addition to that, to realize that requires software tools. And so I don't know if there's, probably not, but there's a need of software tools that include AI for top-down type of system analysis, design, and simulation. So for example, in our programming class, we usually start with bottom-up type of programming. But then when we get to the senior level capstone design project, we teach them more like a top-down application software, like graphic-based rather than text-based. So it's based on the top requirement and then flow down to each nuts and bolts. And then the sort of different tool comes in. And I think the tool that those kind of top-down type of tool that would include AI, because top-down type of tool in our area is already very complete, a lot of components, but it lacks AI components. And so having AI as part of this would definitely become a very powerful engineering solution tools that's used for later part of student educations after they do this sort of bottom-up nuts and bolts type of text-based programming. And so that's sort of my wish list, that cross-major collaborations and sort of create software, hardware examples, and that would be sort of closer to our application would be very much needed. And I definitely see how company would be contributing in this area, as I've seen some announcement of product that's sort of moving to these directions.
Mm-hmm. Okay, and if we can have just sort of like really, I'm sorry, gentlemen, short answers. Yes, so cooperation between AI educators, AI companies, hardware makers, like possibly governments. Like, what do we do to make it happen? If we could, yeah, Professor Shen, please.
Yeah, I think one thing that is, I think, quite unique about the AI education is that there is obviously a need for a significant amount of data. This is something that educators alone, I think this has been kind of mentioned by Professor Li before. We cannot really have that. We cannot create that in a small scale class, in each university. So this is a part that I think relying on industry university collaboration really makes sense. The other part, obviously, is also in the AI field, the tools are evolving really, really quickly. When I say tools, I mean both hardware and software tools. So universities, again, cannot just rely on some standard tools for many years to come. They have to basically adjust based on what the field, where the field is moving to, because at the end of the day, the students we are educating are the ones that will be contributing to the workforce of these companies. So it's better for them to be trained with the tools that are state of the art. So I think these two fields are really the ones that we, at least in my mind, need collaboration the most from companies. And in the meantime, I think the companies also benefit from such collaboration because as I said, we grow the workforce. I think it's better for everybody that's involved in this business. So.
Yeah, absolutely. It's just like it's part of every technological cycle, like you equip, so like the researchers with the latest and greatest, and you're gonna harness the benefits for years to come. And I think something similar happened in storage, Professor Li. So yes, what would you want to see? What kind of participation would you want to see from the private sector and from the people who like design commercial silicon?
I think from hardware vendors' companies' perspective, I think they like to make products that people can use. From educators' perspective, I think we want students to learn how to make this new generation hardware. I think that's where the producer-consumer type of relationship, right? So as Professor Shen mentioned, I think it would be helpful if there's more sharing going on. I think that one of the challenges in educating students to figure out how to design hardware is that there's no convenient hardware environment for them to run a real project. For example, if you want them to program a field programmable logic array, like FPGA, gate array, then there's no there's not enough higher level tool for students to program, to design their idea that make them work very easily, right? So I think even designing software stack or the system software stack and try to modify them, I think it's also new thing because that's a moving target. So even though there are many open source systems, they're all quite complex. Like if you want to modify TensorFlow software stack or PyTorch software stack, it's quite involved. It's not like students can figure out how to do within a week or two. So what you want is that students can do things in a week or two and actually make progress. They can see a baby system from beginning to work. I think, when I back then just do a contrast or some kind of comparison. When I was teaching computer architecture course, I was able to develop, for example, 9 small projects, one after the other, one built on top of the other. In the end, student would have a processor, a general purpose processor, but very simple processor, and running with a CAD tool, like a Cadence or some other CAD tool. They can actually run, and they can run assembly language program on the processor they actually designed. And this can be done in one semester. We don't have something similar to this, right? And even, for example, when I was teaching operating system course, we have 6 project series, from building a bootloader and to actually building, virtual memory system that run user kernel mode and a simple file system. So students at the end can run a game on their OS and running on the Intel processor. So this can be done in one semester also. We don't have anything close to this for machine learning. And that's a challenge. So if the company could, inside the company, each company has their development tool chain, right? And typically they're not really sharing the tool chain with the universities yet. They're not open sourced it because they worry about competition and so on and so forth. I think if they're more open type of tool chain for educators to use, actually close to real, students can see from the beginning of design something to the end actually something work. I think that would be very satisfying for students. And also very good for companies to see such students. For example, back then when I was teaching OS course, students were able to design OS from the beginning to actually have something running. Those students are highly demanded in the Silicon Valley because they can answer all kinds of questions you come up with about OS because they have done from the beginning to something, even as a toy, right? I think that we want students to be able to do that if you design hardware.
Okay. Well, yep, certainly. If any, like AI software, hardware vendors are listening, there's the space for an open source kind of developer stack that could be easily demonstratable to students. But I'm afraid this is everything we have time for today. So many thanks to all of our participants. Thank you for sharing, like your learning from a lifetime of learning. Thanks, Kneron, for hosting this meeting. And if you want to find out more about sort of like the latest about on AI in business, go visit aibusiness.com. But thank you for watching.
Thank you.
Thank you.